when I think about our customer base and what they are looking for, so normally for us, within Memphis, we try to show all the memory technologies which are available. So the emerging memory technology like MRAM, FRAM, ReRAM, all these kind of memory technologies, which is not really emerging, you know that. But frankly speaking, we know that kind of 95% of the memory market is DRAM and NAND. Okay?
Right.
I normally see especially Ferro and MRAM as the most strongest one, which can be on product and on wafer level succeed because of AI. Can you tell me a little bit why suddenly, especially the last couple of months, this is popping up more strongly? What is the benefit, for example, for FerroeRAM on an AI application? Why this could be interesting?
There's a lot of hype recently for all non-volatile, Ferro, MRAM, organic, RAM. I see a lot of companies, startups, especially in Asia, doing it.
Mm-hmm.
Why do they do it? There are some specialty applications where you can live with the deficiency of those technologies. Now my statement is a little bit hard. Those technologies we talked about, EUV is so expensive, 20 times below wavelength. All those technologies are basically garbage. In flash, you need a controller to do wear leveling, all kinds of things, block certain areas where you detect faults after a while, reshuffle the data into the memory because it's garbage. Because those technologies are beyond the edge of physics and you will never get a perfect part. So you have to do more and more things to live with this imperfection.
Mm-hmm.
ECC, on-chip error correction. For a couple of years, every DRAM has now on-chip error correction. Flash, stacking many transistors above each other. You get faults, you get problems. A flash, you cannot really test. If you would test the array 100 times, it falls apart.
Mm-hmm.
So poor is the quality of the semiconductor we have to work with and make it a reliable product.
Mm-hmm.
So this is the challenges for all those technologies, Ferro, MRAM, RAM. I know a company doing an RAM for a special OLED application where you have to write it only once. To calibrate the screen, and then you only read it.
Mm-hmm.
Because you can only write it 10 or 20 times, then the cell would be destroyed. So you need a very special application that might be justified. And the trend you see everywhere. If you go to a tester conference, a big topic these days is silent data corruption.
Mm-hmm.
So the server farm operator were surprised that sometimes you do a mathematical calculation. There's a very famous formula. I think it's 1.1 to the power of 53. The correct answer would be 169. Sometimes the CPU says 0.
Mm-hmm.
Or in server farms, they frequently store information, FTP, somewhere. Then later, when they need it again, they restore it. And then they find, oh, a file is missing. So this is called silent data corruption. It has nothing to do with the memory, the DRAM.
Okay. Mm-hmm.
There we have ECC. The server
Right.
farms detect immediately if there's
Right.
an issue and correct it. But not for the CPU.
Okay.
Not for the CPU.
Mm-hmm.
And this is especially bad for AI applications, learning. You have an algorithm, 1,000 pictures, 500 men. You teach, oh, this is a man. 500 women, oh, this is how a woman looks like. And now the CPU makes a mistake. Oh, you present a woman picture, but say, oh, this is a man. This is very detrimental for all those AI learning algorithms.
Mm-hmm.
So they are scared to death by this silent data corruption. So what do they do? So one use case for those emerging memories will be this NVIDIA processor is so expensive. All 30 minutes they stop it. They store the memory into NAND flash,
Mm-hmm.
takes a while, maybe 2 minutes, then they continue computation. Do they detect silent error?
Mm-hmm.
Detection happened on the CPU, then they go back half an hour, previous status, upload half an hour previous, and compute from there again.
Okay.
To avoid
It's kind
this.
of a backup, a short-term
Exactly.
backup.
Well, that costs a lot of money.
Of course.
If all 30 minutes, you need 2 minutes to stop those expensive CPUs, 50,000 CPUs doing learning.
Right.
That's a lot of dollars in
Right.
3 years you waste. So that's one.
So that's a usage case for
That's a usage
FeRAM, for example?
For example, any non-volatile which has the performance of a DRAM, that you can replace the DRAM in your server fast and you don't have to save it to flash, which takes time and is slow. You have it permanently in your memory already.
Right.